Good morning or afternoon, ladies and gentlemen. So, here we are, moving into lesson 11. As I said in our last video, we are going to be taking all of these things that we've been doing, putting together the fraction to represent our constant speed, taking that, putting it into our equation, using that equation to fill out a table. And I said the next step was going to be taking that table and then using it to fill out a graph, or to graph particular points. Here we are. So with example 1, this is where we're going to be. It's on page 105 in your book. So we're going to walk through lesson 1, or walk through example 1, just on essentially how we take what we did in lesson 10 and then build on it here. So let's read it. Pauline mows a lawn at a constant rate. Suppose she mows a lawn that is 35 square foot in 2.5 minutes. What area in square feet can she mow in 10 minutes and then t minutes? So t representing any amount of time. All right. So what they're asking us to do is to use this rate. This is no longer our constant speed rate. Now what we're looking at in terms of distance over time is now we're looking at square footage over time. All right. One of the things that you'll see as we go through several examples, both in the book and in the real world even, is that time is often your independent variable. It is your x-axis variable. All right? So time is the one that is going to be changing. Time is the one that is going to be our x value. So when we create to find, as we did before, we did y was, or c, our constant rate was equal to y divided by x. Okay? And we made that to be distance divided by time. With this particular one, we're going to use distance divided by time with y and t. And the reason we know that is because if we look down here at our table and we look down here at our graph that's given to us, they already tell us what variables they want us to use. They want us to use t for time and y for our area. So now our equation is y over t. We're still going to use the same exact values like we did in prior examples. We're going to use the values that are given to us. In this case, our area being 35 feet. 35 foot square lawn in 2.5 minutes. So 35 divided by 2.5 is now our constant, rate. In this case, our constant, we don't really have a speed, but we'll still call it our C, okay? Or we've called it a K, we're going to call it an M later on. It's got many different letters that represent it, unfortunately, but nonetheless, it's still the same value, okay? So now they want to know how many square feet she can do in 10 minutes. So we're going to take our proportion here, 35 over 2.5, and we're going to set that equal to some amount of square feet in 10 minutes. Okay? Some amount of square feet in 10 minutes. What we need to do is we need to cross multiply. So we need to do 35 times 10, and then 2.5 times y. So we get 2.5y is equal to 350. Divide both sides by 2.5 and get 350 divided by, grab a calculator, 350 divided by 2.5 gives us 140. Okay, so our y value is 140. So that means in 10 minutes she can mow 140 square feet. Okay. It's important that we relate everything back to its original equation, or back to its original question, rather. So 140 square feet, that's not the entire answer. It's 140 square feet mowed in 10 minutes. Okay, we need to refer back to that because we're dealing with now two variables. No longer just x, or no longer just y. We're now dealing with both as we are taking it to the next step of solving equations, using equations, and then graphing equations. We need two variables on a coordinate plane. So in t minutes is essentially a trick question. They essentially just want you to use this fraction up here and then plug that into your equation. So your equation should look like this in your linear equation here. 35 over 2.5 x. Okay? Just like that. 35 divided by 2.5 times x is equal to y. Okay? Now we're going to move on to the bottom part down here. So, the next step is to fill out this table. We're going to use this equation to fill out the table. Now, they asked us about 10 minutes, okay? And this is where it kind of takes a little bit of intuitive thinking. They asked us about 10 minutes, and they gave us a coordinate plane, or a section of coordinate plane for us to, assumably, graph the points that we create here. Our x values go 0, 1, 2, 3, 4, 5, 6, 7. They don't go very far. So, we need to use some of these and then plug those into our table first in order to get our y values to then create our points to place. See what I mean? So, in 0 minutes, okay, in 0 minutes, well, she hasn't mowed anything. She hasn't started. Her time hasn't begun. So when we plug 0 into our equation of 35 divided by 2.5 times 0, we're going to get 0 square feet. Okay? So our point is 0, 0. Okay? 0, 0. We're going to place that point right down here on our graph. Our t value is 0, our y value is 0. Creates an ordered pair of 0, 0. Point goes right here at 0, 0. The next one, 1. So now we're going to do y equals 35 divided by 2.5 times 1. So we're going to do, because this is a fraction, I'm going to multiply the whole number times our numerator first and then divide it by our denominator. So I'm going to do 35 times 1, which is obviously 35, divided by 2.5, which is 14. So that means in 1 minute, she can mow 14 square feet. So we're going to move one space to the right, because we're leaving 0 as our t value, our x value. We're moving 1 to the right, and we're going to go up just under 15 here to make it 14. So our x, put that for our order pair, 114. Our x value is 1, our y value is 14. Okay? So, for those of you doing kind of the calculations in your head, this value right here, this 35 divided by 2.5, we can actually reduce that down to just 14. So that's what I'm going to do for the next one. Okay? We're going to go 2. And instead of our equation being, I'm just going to call that 14x now in our equation. So y equals 14x. So I'm going to say y equals 14, and now times 2. 14 times 2 is 28. So our ordered pair is 2, 28. And so we move one more space to the right, and in this case go up to, let's call it right about there-ish, 28, 228. Now, before we move on, I want to be very clear. Look at what's happening to our t values and our y values as we progress along in filling out this table. Okay? So, when we increase our x value by 1, what happened to our y value? We went from 0 to 14. So that was an increase of 1 here and an increase of 14 here. That should make sense. Our rate of change, our constant rate, our slope, our constant proportionality is 14. So whenever we change x by 1, y should change by 14. So let's double check that here. As we go from 1 to 2, again, an increase of 1 for x. And what happens to our y value? We go from 14 to 28. Again, an increase of 14. This is what represents a proportional relationship. something that where you increase your x value by a certain amount, and your y value also increases by a certain amount each time you increase your x value. You can tell how much you're going to increase by looking at your constant, your coefficient in your equation. Okay? So let's move on to 3. Y equals 14 times 3. 14 times 3 is 42. So our ordered pair is 3, 42. And then we need to place 3, 42 on our table, or rather on our chart, on our graph, whatever you want to call it. Again, we increase x by 1. Y should increase by 14. Indeed it does. And so before we don't even technically really need to plug it in. We could just add 14 to 42 to figure out what, if we increase this by 1, okay? So again, we increase this by 1. We have to increase our y by 14. We already know what that is. We know what 42 plus 14 is, and that's going to be 56. But we can prove that as well by doing y is equal to 14 times 4. 14 times 4 is equal to 56. Wonderful. So now this data point is 4, 56. So we're going to tag that onto this here, 4, and up to just past 56. Okay? Now this is a proportional relationship. So what that means is, with this being a linear equation, we should have a straight line, or about as straight as we can get, since we're not dealing with individual points landing on here. Okay? It needs to go through 0, 0. Okay? And here's our line to represent our rate of change. This line is called y equals 14x. This is the start of what we do. I want you to see step by step what is required for us to take from the original equation, which had to deal with mowing the lawn at a certain rate, taking that rate, putting it into our equation, using our equation to fill a table, using that table to create a graph. This is what we need to be able to do for the final end step. Granted, this is our first one. There will be more. We will get more practice in this. Okay? Make sure this is done just the way I did it, just the way I've shown you. I want you to try some of these other ones on your own, like on page 106. Example 2 gives you some nice numbers. You'll be great there. Try it on your own. Let me know how you do. Send me an email if you have any questions. And then after you try that, you can work on your assigned questions to do. Adios.